we don't know p, so we need to estimate it. So as usual, we can collect some data and see how to use that data. Let's say that we collect m samples, each of size n. Within those samples, we track xi, which is the number of defectives, non-conforming units in a sample. And we can also collect values of pi hat, which is equal to xi over n, which really gives me the fraction of defectives. Now, if we want to estimate the population parameter p of the random variable, which is the mean value of p hat, then we can estimate it with the average value of this pi hat over m. So we take the proportion in each of the samples, and then we divide it by the number of samples. Now this can also be written as xi over n, which is the fraction of defectives in the sample, and then this can also be written as xi over nm. So we can add the total number of defectives in all our m samples, and we can derive it this way. Any way we derive it, we will call this as p bar. And now that we have p bar, which can be computed any number of ways, we are now ready to write down our control chart. So the p chart, we now have, let's note here that this will be the center line if we only knew p, and this would be a standard deviation if we only know p. Well, we have p bar as an estimate. The center line will be p bar, and as usual, plus or minus 3 standard deviations, which will be p bar 1 minus p bar divided by n. And this here is our p chart, which we can now use to monitor the performance of these fractions. And we will deal with some related issues in the next videos, and also generate a p chart using our simulation and Minitab.